What if the most important message from Saturn arrived years after the spacecraft that sent it was already dead? What if the final pictures from Cassini were not the ending of the story, but the moment the real mystery began? And before we go deeper, do this with me right now. Tap, like if space still gives you chills. Subscribe if you want stories that make the universe feel close, and share this with one person who loves the unknown as much as you do. On September 15th, 2017, NASA ended one of the boldest missions in history. Cassini, a spacecraft that had spent years exploring Saturn, was deliberately sent into the planet's atmosphere. The reason was simple and serious. Scientists did not want to risk the spacecraft crashing one day into worlds like Enceladus or Titan, moons that might hold conditions important for life. So instead of letting Cassini drift out of control, they gave it a final assignment. Dive into the unknown, keep transmitting as long as possible, and die doing science. That alone would have been unforgettable. A machine built by human hands, launched in 1997, arriving at Saturn in 2004 after a 7-year journey, then surviving for more than a decade in one of the most extreme environments in the solar system. By the time its mission ended, Cassini had already changed textbooks. It had shown us methane seas on Titan. It had revealed towering plumes of water ice blasting from Enceladus. It had given us astonishing views of the rings, storms, and moons of Saturn. It had done enough for several lifetimes of discovery. But then came the grand finale. In its last phase, Cassini did something no spacecraft had ever done before. Over 5 months in 2017, it made 22 daring passes through the narrow gap between Saturn and its innermost rings. That gap was about 100 miles wide. It may sound large, but in spaceflight terms, it was a razor-thin target around a giant world. No one had ever explored that region directly. Nobody knew exactly what was waiting there. Dust, debris, dangerous particles, or measurements that could answer questions scientists had wrestled with for years. NASA took the risk because this was the only chance left. Cassini was running low on fuel. If the mission waited, the opportunity would vanish. So the spacecraft kept diving. Each pass brought it closer to Saturn's clouds, closer to the rings, closer to data that had been out of reach for the entire mission. Its cameras looked outward. Its instruments sampled the environment around it. It measured gravity. It measured the magnetic field. It studied ring particles. It watched the planet from angles no one had ever seen before. Then, just before the final plunge, Cassini sent back its last images. They were beautiful, yes. You could look at those final views and feel the emotion instantly. Saturn's rings looked fragile and majestic at the same time. Titan appeared distant and haunting. Enceladus, bright and cold, looked almost innocent. To the public, it felt like a farewell album, the final goodbye from a spacecraft that had given us so much. But scientists knew something the rest of the world did not fully grasp. Pictures are only part of what a mission like Cassini brings home. Behind every image is a flood of numbers. Hidden in that flood are patterns, chemistry, motion, temperature, dust, tiny changes in gravity, tiny changes in radio signals, tiny shifts in how a moon wobbles, how particles move, how a magnetic field behaves. That is where the deeper story lives, and that story does not always reveal itself right away. Sometimes, spacecraft sees more than the human mind is ready to understand. That is exactly what happened with Cassini. Even after the spacecraft was destroyed, its data stayed alive. Years later, researchers kept going back to the archive and finding new meaning in old measurements, better analysis tools, better models, better questions. That is one of the most powerful things about science. A mission can end, but the discovery does not end with it. In some cases, the most shocking result comes later, when someone looks again and sees what everyone missed the first time. That is why Cassini is still changing our view of the solar system. Start with Saturn's rings. For generations, those rings looked permanent, almost timeless. If you asked most people to picture Saturn, they would imagine a giant golden planet wrapped in bright, elegant bands of ice. It feels impossible to separate Saturn from its rings. They seem like part of its identity. But Cassini's measurements push scientists toward a very different idea. The rings may not be ancient at all in cosmic terms. NASA-backed studies using Cassini data found that the rings appear relatively young and short-lived. They are being polluted by constant impacts from tiny space debris, and they are losing material as that material drifts inward toward the planet. In other words, the rings are not frozen in time. They are changing. They are being worn down. They may last only a few 100 million years more. Think about what that means. Dinosaurs may have lived on Earth before Saturn even wore the rings we know today, and if human beings had emerged much later in cosmic history, we might have seen a very different Saturn, maybe one with much fainter rings, maybe one with none at all. One of the most iconic sites in the solar system may be temporary. That changes the emotional meaning of those final Cassini images. They are not just beautiful, they are a record of something fragile. And Cassini did not stop there. During the grand finale, the spacecraft made some of the best measurements ever taken of Saturn's gravity and magnetic field. One of the strangest results involved the magnetic field itself. Saturn's field appears astonishingly well aligned with the planet's rotation axis. That sounds like a small detail, but it is a serious scientific puzzle. Planetary magnetic fields are not supposed to behave so neatly. The deeper scientists look, the more Saturn seems to be telling us that our models are still incomplete. That is one of the recurring themes in this entire story. Cassini did not just answer questions. It exposed the limits of the questions we were asking. Then there's Titan, Saturn's largest moon. Titan is one of the strangest places we have ever studied. It has a thick atmosphere. It has rivers, lakes, and seas on the surface, though they are made of methane and ethane, not water. For years, many scientists believed Titan also likely had a global liquid water ocean hidden beneath its outer shell. That picture made Titan even more fascinating. It seemed like a layered world with alien weather above and deep water below. But a recent reanalysis of Cassini data challenged that idea. According to a NASA Jet Propulsion Laboratory study, Titan may not have a global subsurface ocean after all. Instead, its interior may be dominated by ice, slushy layers, and pockets of warm liquid water near the rocky core. That might sound less exciting at first, but it is actually one of the most important lessons Cassini keeps teaching us. Real science is not a machine that exists to confirm what we hope is true. Real science corrects itself. Cassini keeps doing that even from the grave. The data from Titan tells us something bigger than one result about one moon. It tells us that our first interpretation is not always the final one. The universe does not care what story we prefer. It only gives us evidence and then asks whether we are humble enough to follow it. If that were the only surprise buried in Cassini's archive, it would already be enough to make this mission legendary. But then we get to Mimas. If you know Saturn's moons, you probably know Mimas as the one that looks a little like the Death Star. For a long time it seemed like one of the least likely places to hide a major secret. Its surface looks battered, ancient, frozen, and quiet. Not the kind of world that makes people whisper about hidden oceans. Not the kind of world that seems alive in any scientific sense. And yet Cassini data kept hinting that something was wrong with that simple picture. Years ago, researchers studying Mimas noticed that the moon wobbled in a way that did not fit cleanly with expectations. One possibility was that something unusual was happening inside. Then later work strengthened the case that Mimas may contain a global ocean beneath its icy shell, perhaps only 20 to 30 kilometers below the surface, and that this ocean could be surprisingly young in geological terms. Pause on that for a second. A moon that looks dead on the outside may be hiding liquid water on the inside. This is where the Cassini story starts to feel almost eerie. Again and again, the mission tells us not to trust appearances. A cratered shell does not guarantee a frozen heart. A familiar image does not mean a simple reality. The Saturn system keeps rewarding anyone willing to look beneath the surface. If you're still with me, hit the like button like you're backing a mission you wish had 10 more years. Subscribe for deep space stories without the fluff. And send this video to a friend so they can say they heard the truth about Cassini before everyone else catches up. And now we come to the discovery that changed the emotional center of the entire mission, Enceladus. Before Cassini, Enceladus was not one of the biggest stars of the solar system. It is small, bright, icy, easy to underestimate. Then Cassini found enormous plumes erupting from its south polar region. Water vapor and ice grains were shooting out through cracks in the ice, feeding Saturn's E-ring and turning a small, frozen moon into one of the most important places in astrobiology. Over time, mission data built a remarkable picture. Beneath the frozen crust of Enceladus lies a global ocean. Cassini found evidence that this ocean is salty. It found signs consistent with hydrothermal activity, the kind of hot water and rock interaction that, on Earth, creates chemically rich environments on the seafloor. It also found organic compounds, not proof of life, but something almost as important at this stage, proof that Enceladus is chemically active in ways that matter. Then came a new analysis of particles collected directly from the plume. This is where the story becomes truly astonishing. Scientists studying archived Cassini data reported evidence of previously undetected organic compounds and fresh ice grains from Enceladus. Not old particles that had spent years drifting around Saturn's E-ring. Fresh material much closer to its origin below the surface. According to NASA's Jet Propulsion Laboratory, the newly detected compounds included aliphatic and cyclic esters and ethers, along with other confirmed aromatic, nitrogen-bearing, and oxygen-bearing compounds. That sounds technical, so let's say it plainly. Cassini found richer and more diverse chemistry and fresh material from Enceladus than we had confirmed before, and that matters because chemistry is the bridge between a dead world and a living possibility. On Earth, some of these kinds of molecules are tied to processes and structures that are deeply important to biology. No, this does not prove there is life in Enceladus' ocean. Anyone telling you that is going too far. But it does show that the moon has the kind of chemical complexity scientists care about when they ask whether a world could support life-related processes. That is a major difference. It moves Enceladus from interesting to urgent. And there's another detail that makes this even more powerful. The particles in that study were collected when Cassini flew through a plume in 2008, just 13 miles above the surface. The grains were essentially fresh from the hidden ocean. In other words, this was not chemistry guessed from a distance. This was chemistry sampled from material that had just been thrown into space from below the ice. That means Enceladus is not just a world we can admire. It is a world that is offering us samples. Imagine how extraordinary that is. Somewhere beneath miles of ice, on a moon orbiting Saturn, water touches rock in darkness. Heat moves through that hidden sea. Molecules form, pressure builds, cracks open, and then some of that ocean rises and sprays itself into space where a passing spacecraft can taste it. If you were designing a target in the solar system to test questions about habitability, you could hardly ask for a better gift. This is why Enceladus now stands near the top of the list whenever scientists talk about ocean worlds, not because life has been found there, it has not, but because the moon keeps meeting one important condition after another: liquid water, energy, organic chemistry, exchange between the ocean and the outside environment. Each new layer does not close the case, it sharpens it. And the emotional force of this discovery comes from timing. Cassini did not announce this in its final dramatic live moments as it plunged into Saturn. The spacecraft did something quieter and, in some ways, more profound. It delivered data so rich that the meaning unfolded slowly, year after year, paper after paper. The mission died in 2017. The consequences of what it found are still arriving. That changes how we think about exploration itself. We often imagine discovery as a single moment. The light turns on. The scientist gasps. The headline appears. Everyone understands what changed. But Cassini reminds us that real discovery can be delayed. Sometimes the signal arrives before the meaning. Sometimes history sits in an archive until somebody asks a smarter question. That is why the phrase "final images" can be misleading. Those images were real. They were moving. They mattered. But the deeper shock was not in the beauty of the farewell. It was in the invisible information still hiding behind the farewell. And once you see that pattern, the whole mission feels different. Cassini becomes more than a spacecraft that visited Saturn. It becomes a messenger whose final words are still being translated. That idea is not poetic exaggeration. It is physically true. When Cassini made its final plunge on September 15, 2017, it kept sending data for as long as its thrusters could hold the antenna toward Earth. The signal then had to cross the enormous distance between Saturn and our planet. By the time the last transmission reached Earth, the spacecraft itself was already gone. For a brief span of time, Cassini had already died, and its voice was still traveling. That image is hard to forget. A machine destroyed inside a giant planet, still speaking across space. And what was it saying? It was saying that Saturn's rings are not eternal ornaments. They are active, changing, and vulnerable. It was saying that Titan may be stranger and more complicated inside than we assumed. It was saying that Mimas, a moon once dismissed as a frozen relic, may hide liquid water beneath an old scarred face. And above all, it was saying that Enceladus deserves our full attention. Because if you step back and look at everything together, the Saturn system no longer looks like a simple collection of cold moons orbiting a gas giant. It looks like a laboratory of hidden oceans, chemical energy, and layered possibilities. It looks less like a finished picture and more like a set of unopened doors. That is the real shock. The closer Cassini got to the end of its life, the more it pushed us toward one of the oldest questions human beings have ever asked. Are we alone? Not in some distant galaxy we may never reach, not only around faraway stars, but here in our own solar system, inside dark oceans beneath ice. That question hits harder because Enceladus changes the rules of where we look for life. Life on Earth does not depend only on sunlight. Deep in our own oceans, entire ecosystems survive around hydrothermal vents. They draw energy from chemistry, not from daylight. That means a world does not need to look like Earth on the surface to be biologically interesting. It can be frozen above and active below, silent outside and dynamic within. Enceladus fits that possibility in a way that is almost unsettling. A small moon, a hidden sea, organic compounds, evidence of interaction between water and rock, plumes that carry that story into space. When you line those facts up, the moon stops feeling like a distant object and starts feeling like a direct challenge to our assumptions. Maybe life does not need broad continents, blue skies, and warm sunlight. Maybe sometimes all it needs is water, chemistry, energy, and time. If this story has changed the way you look at Saturn, subscribe now and stay on this journey with us. Drop a comment with the one Cassini discovery that blew your mind most, and share this video with somebody who still thinks the outer solar system is just empty, cold rock and ice. There is also something deeply human in the way this mission ended. We built Cassini to survive in the dark. We sent it billions of miles away. We trusted it to operate where no repair crew could ever reach it. For years, it flew past moons, through radiation, across shadows, and along the edges of the unknown. Then, when the fuel was nearly gone, we did not simply switch it off. We gave it one last impossible task. Go where we have never gone. Measure what we have never measured. Risk everything. Give us one final gift. It did. That matters because space exploration is often described in terms of machines, budgets, and timelines. Those things are real, but they are not the whole story. Missions like Cassini are also expressions of belief. Belief that the universe is understandable. Belief that patience is worth it. Belief that a question asked today may be answered years later by data gathered in silence far from Earth. Cassini rewarded that belief again and again. It rewarded it when it showed us Titan's alien seas. It rewarded it when it revealed Enceladus as an ocean world. It rewarded it when it turned the rings from decoration into evidence. And it rewarded it one final time by leaving behind a data archive that scientists are still unpacking, still testing, still learning from. That may be the most impressive part of the entire mission. Cassini was not designed to give us one neat conclusion. It gave us a living legacy, a body of evidence big enough that each new generation of researchers can return to it with better methods and find something new. And that living legacy is already shaping the future. Scientists are not talking about Saturn now as a place we visited and understood. They are talking about it as a system we urgently need to revisit. Every result from Enceladus raises the value of sending a mission that can sample plume material again with instruments far more advanced than what Cassini carried. Every surprise about Titan strengthens the case for going there with fresh eyes and new tools. Every hint from Mimas reminds us that even the quietest-looking moon can hide an active interior. Cassini did not just answer old questions. It helped write the shopping list for the next generation of exploration. That matters because discovery does not move in a straight line. First comes the daring mission. Then comes the mountain of data. Then comes the slow work of analysis. And finally comes the moment when humanity decides whether to go back. This time with sharper tools and bolder goals. Cassini has pushed us right to that edge. In other words, Cassini is gone, but its mission is not over, in the only sense that finally matters, because a mission is not truly finished when the hardware is lost. It is finished when the questions stop growing, and Cassini's questions are still multiplying. How active is Enceladus's ocean right now? What exact pathways produce those complex organic compounds? Could future missions sample the plumes more directly and search for stronger biosignatures? How many ocean worlds are hiding beneath old, frozen surfaces across the outer solar system? What exactly is going on inside Titan? What else have we missed in the ring data, the gravity data, the magnetic data, the dust data? Those questions matter because they shape what comes next. Future missions will be chosen, funded, and designed around them. Instruments will be built because of them. New careers in planetary science will be launched because of them. Students who were children when Cassini died may be the ones who finally answer them. That is how big discoveries really work. They do not end with applause. They create pressure. They pull the future toward them. And few missions have done that as strongly as Cassini. So when people say Cassini's final images shocked the world, the deeper truth is even more powerful. The shock was not only that the images were beautiful. The shock was not only that the mission ended with such courage. The shock was that the ending kept turning into a beginning. Every few years, the archive seems to open another door. Another moon becomes stranger. Another assumption gets corrected. Another clue appears in a particle, a wobble, a signal, or a model. And the closer we look, the more the Saturn system begins to feel less like a distant monument and more like a place full of active processes happening right now. Right now, ring material is moving and changing. Right now, Titan may be cycling heat through slushy interior layers. Right now, Mimas may be hiding liquid water under an ancient shell. Right now, Enceladus may be producing complex chemistry inside a dark ocean. And right now, the most important evidence for all of that is still being read from a mission that ended years ago. That should change the way we think about old data. Old data is not dead data. Not when the tools improve. Not when the questions deepen. Not when the universe was speaking more clearly than we first realized. So maybe the real lesson of Cassini is this. Sometimes the universe whispers before it shouts. Sometimes the breakthrough is already sitting in the archive, waiting for us to become smart enough, careful enough, and patient enough to understand it. And sometimes a spacecraft's last act is not to close a chapter, but to hand the future a mystery so powerful that we spend the next decade trying to catch up. That is what Cassini did. It flew into Saturn and disappeared, but instead of giving us closure, it gave us unfinished wonder. And maybe that is why those final images still hit so hard. Because when you really understand what they were attached to, they are not just pictures of a distant planet. They are the surface of a much deeper message. A message about worlds under ice. A message about chemistry on the edge of biology. A message about how little of our own solar system we truly understood. A message sent from a spacecraft that died doing exactly what we asked of it. Go farther, look closer, and tell us what is there. Cassini did. And the most astonishing part is that we are still hearing the answer. If this story stayed with you, don't just watch and move on. Subscribe so you don't miss the next mystery. Share this with someone who needs a reason to look up tonight. And like the video so more people can discover how one spacecraft's final fall may have opened the next great search for life. The final images were never just a goodbye. They were evidence. They were warning. They were invitation. And if the hidden ocean of Enceladus really is as chemically alive as Cassini suggests, then somewhere beneath that frozen crust, in darkness nearly 1 billion miles from Earth, the universe may be telling us that life is not rare because it is fragile. It may be rare only because we have not learned where to listen. That is why Cassini still matters. That is why Saturn's final messenger still speaks. And that is why this story is not over.